Hello everyone, welcome back to my another video on linear regression. Now in this tutorial we are going to implement linear regression using Python. So as we saw in our previous lectures that linear regression uses the relationship between the data points to draw a straight line through all of them. Now these line can be used to predict future values or known variables. So in machine learning the predicting the future is very important. Now let's implement this from scratch in Python. So you can see that the problem statement is X is a dataset representing how old the car is and Y is representing the maximum speed the car offers. So the goal of this model is to actually find the speed of a car using unknown variable X, which is specifically not present in the dataset. So the first thing I will do is create a scatter plot. For that I need matplotlib, which is library for creating various plots. So I will import this. It's matplotlib. And the second thing I will do is to create my dataset, which are X and Y. So let's say X is representing how old the car is. So 5, 7, these are my ages of car, how old the car is representing. Now X is my dataset which is representing how old the car is. Now next thing we implement is Y, which is the dataset representing how fast the car is. So we have finally made the dataset. So X is representing my age of a car and Y is the top speed which the car offers. Now the goal is to find Y based on X. So what I will do is I will just plot this. So I will scatter plot this. So all I need to do is to make this scatter function and finally I will show the dataset. So you can see a figure coming out there which is representing the scatter plots of X and Y. Now right after drawing the scatter plot, the next thing we want to do is to put the best fit line using linear regression. So for that I will be using one library called SciPy, which is used for scientific computing. So from SciPy I will go and import a library called stats. So the next thing I want to do is to print these parameters. Now let's understand what this line is doing. So the first thing, slope, this is the slope of the best fit line, also called as linear regression line. So it represents how much y changes for each unit increase in x. So mathematically it's actually the coefficient of x in the equation of line y equal to mx plus c, as we saw in our previous video. Intercept represents the y-intercept of the best fit line. It represents the value of y when x equal to 0. Now it's the point where the regression line crosses the y-axis. Next we have r. This is also called as correlation coefficient. It quantifies the strength and direction of linear relationship between x and y. Now the value of r lies between -1 to 1. So when r is equal to 1, it represents a perfect positive linear correlation, and when it is -1, it represents perfect negative linear correlation. And when r is actually 0, there is no linear correlation between x and y. Next we have p. So this is the p value for testing the hypothesis that the slope of the regression line is 0. So a low p value suggests that the linear relationship is statistically significant. So finally we have standard error. So this is the standard error of the estimated slope. Now it measures the accuracy of the slope estimate, and the smaller standard error actually indicates the more precise estimate of the slope. And we have done this and we have fitted this inside x and y. Next we define a function and then return mx plus c, which is slope into x plus intercept. Now this seems to be equivalent with this equation y equal to mx plus c, where m is my slope, x is what the input variable is, and c is my y-intercept. Next we create a variable called mymolar and then save it into a list format where we map the input function myfunc and x. Finally we then scatter plot x and y, and then we show this. So you can see we are getting a best fit line. Now from this we can go and then predict the unknown variables. Now let's see what is R. So R would actually represent the relationship between X and Y. So there seems to be a negative correlation which is quite strong since it is closer to 1. And let's now predict the future values of the unknown variables. So in this scenario you can see that my X does not contain the speed of a 10-year-old car. So let's go and then find the value of a 10-year-old car. So all I need to do is to apply those functions of 10-year-old car, and then if I print my speed, all I get is the speed of my 10-year-old car. So okay, my function name has an underscore there. Okay, now you can see that the speed of a 10-year-old car is 85.59 kilometers per hour. So with this, we can conclude that using linear regression, we can find the values of an unknown variable or the future variables.